So in this video, we're going to take a look at how we can factorize particular types of trinomials. And what I'd like to do first is actually explain what we mean by trinomial. So let's take a look at a few algebraic expressions. For example, x squared plus 6x plus 9. We'll have one over here which is x cubed plus 6x squared plus 2x plus let's say 7. And we'll have one over here that's just x squared plus 16 like that. Now, which of these are trinomials? Well, tri, meaning 3, if you think like a tricycle, okay, we're looking for the ones here that have 3 terms. They will be our trinomials. So for example, this one here has 1, 2, 3 terms. So this one is a trinomial. What about the middle one? Oh, actually, we'll do the end one. What about the end one? This one here, 1, 2 terms. So that one is not a trinomial. In fact, because it has 2 terms, and think about a bicycle, bi meaning 2, we call this one a binomial. And anything bigger, like this one in the middle, 1, 2, 3, 4 terms, anything bigger than 3, we'll just call these guys polynomials. So in this video, we're going to focus in on the ones that look like this with 3 terms. And we're going to look at how we can put these into 2 nice, neat little brackets. To start off with, let's cast our minds back to expanding some of these more than one bracket. So expanding more than one brackets in the last video. And the one that I would like to do is I'd like to expand out x plus 2 times x plus 3. So remembering in the last video how we can expand these out, we do this x to this x over here. We want to create our crab clause. So we get x squared, this x to this plus 3, we get plus 3x. This 2 to this x, we get plus 2x. And this 2 to this 3, we get plus 6. And we can simplify this expression down to become x squared plus 5x plus 6. So I'm just adding this 3x and this 2x together here. And what I want to do now is I want to focus in on how we can go the other way and some of the relationships between these numbers. So now what we're going to do is we're going to get something like x squared plus 5x plus 6. And we need to be able to go back in this direction. And to be able to do that, we need to understand some of the relationships between these numbers in this top line here. So let's focus in on the number 5. What is the number 5? Where's that number 5 coming from? The number 5 is the number 2 plus the number 3. So we need to add these two numbers together to get 5. And what about this number 6 here? Where's that coming from? Well, that 6 is this 2 multiplied by this 3. So we're going to multiply. So when we're doing these problems, when we get something like x squared plus 5x plus 6 here, we need to look for 2 numbers that add to, in this case, the number 5, because that's the one in the middle there, and multiply, in this case, to 6, the number on the end. And the answer here, 2 numbers that add to 5 and multiply to 6 are the numbers 2 and the number 3. So if we were going to factor this, we would have x plus 2, x plus 3, like what we had above here. Let's start from scratch with a fresh example with this little rule here, which we'll leave just up there like that. And we might make this now, instead of 5, we'll say add to the middle, and they have to multiply to the end. So let's take a look at an example. I would like to do x squared plus 8x plus 12. So we need to try and factorize this. And to do so, we need to look for 2 numbers that multiply to give us 12 and they add to give us 8. Well, let's think of some numbers that multiply to give us 12, because there's only going to be so many combinations of numbers that multiply to give us 12. Whereas numbers that add to 8, there's infinitely many. You could go 1 and 7, or 2 and 6, or you could go 3 and 5, or you could start getting creative and go 10 and minus 2, 11 and minus 3, and then it just goes on forever. So let's take a look at numbers that multiply to give us 12. Well, we could have 4 and 3, we could have 12 and 1, Or we could have 6 and 2. And I don't think there's any more. Well, which of these are going to add to give us 8? Well, 4 and 3 would add to give us 7, so that's going to be no good. 12 and 1 add to give us 13, so that's going to be no good. But 6 and 2, they add to give us 8. So our answer here is going to be x plus 6 times by x plus 2. And of course, we can check this by expanding these brackets out. So let's expand them with our crab clause. We get x squared plus 2x plus 6x plus 12. So x squared plus 8x plus 12. Exactly what we needed. So that one there is perfect. Let's do one more example like this before we crack into some negative numbers that start to creep along. So we'll do one more example in the positives. So let's go for factorising x squared plus 12x plus 32. So we're looking for two numbers here that multiply to give us 32 and add to give us 12. Well, let's start brainstorming numbers that multiply to give us 32. So we could have 32 and 1. That's a good one. We could have 16 and 2. We could have 8 and 4. In fact, 8 and 4 looks pretty good because 8 and 4 are going to add to give us 12. So this one here is going to be the correct combination in this case. So if we want to factorise this, we get x plus 8 times x plus 4. And of course, as always, with these problems, we can check our answer by expanding our brackets out. So let's do x times x for x squared plus 4x, and then the 8 to the x plus 8x plus 32. And we can simplify this down for x squared plus 12x plus 32. So that one's worked out perfectly as well. Let's do another example now where we start to get some negative numbers. Okay, so now we've got to start being a little bit more careful. So let's look at, let's go for x squared plus 3x minus 18. Okay, remember, nothing changes. We need two numbers that multiply to give us negative 18 and add this time to give us 3. Let's brainstorm some numbers that can multiply together to give us minus 18. So let's go for minus 18 and positive 1. They multiply together to give us minus 18. Also, the numbers minus 1 and positive 18, they multiply together to give us minus 18. Let's think about some more. Let's go for 9 and 2, so positive 9 and negative 2 maybe. Likewise, we could have negative 9 and positive 2. What about 6 and 3? Positive 6 and minus 3, or minus 6 and positive 3. And I might just rewrite this one at the top to sort of make it look more consistent, like that. Okay, this one's definitely going to work somewhere. One of these two in this line are going to work because there's clearly going to be a difference of 3 between 6 and 3 somewhere along the line. And we just got to make sure we pick the right one. Well, what's plus 6 minus 3? So now we're looking at adding these together. We would get minus 3. Positive 3, sorry. 6 minus 3 is positive 3. What about minus 6 plus 3? That would be minus 3. And which one do we need? We need positive 3 in here. So it's going to be this one here. It's going to be plus 6 and minus 3. So our answer is x plus 6 times x minus 3. And we can check this by expanding these brackets out. And using our crab clause, we get x squared, take 3x, plus 6x, minus 18. And simplifying that down, minus 3 plus 6, plus 3x, take 18. And that's exactly what we needed. So in this case, this one here is how we factorize it. Let's do one last problem. Okay, so one last one for this video. Exact same process applies. Okay, so let's just rub this one out quickly. Let's do one more. Let's go for x squared minus 6x plus 8. Okay, same principle applies. We're looking for two numbers that multiply for positive 8 and add together for minus 6. And let's start brainstorming numbers that multiply to positive 8. So we could have plus 8 and plus 1. We could also have minus 8 and minus 1, right? Because if we multiply two negatives together, we're going to get a positive. What about 4 and 2? Positive 4 and positive 2. Or we could have negative 4 and negative 2. And I'm thinking that it's definitely going to be one in this bottom line here that's going to add or take away somehow to 6, right? It's going to have a difference of 6 somewhere along the line here. So let's explore these bottom two ones. Positive 4 plus 2, so now adding them together, this will give us positive 6. But what about negative 4 minus 2? That would give us negative 6, and we need these to add together to give us negative 6. So in this case, this one here is our answer. So we can factorize this as x minus 4 times x minus 2. And let's expand these brackets out once again just to check that we get the right answer. X squared, so using our crab clause, take 2x, take 4x, and then plus 8. So being very careful all the way through this whole problem with our negatives. And we get x squared take 6x plus 8, which is exactly what we needed at the start of the question. So that is how we can start factorizing some of these trinomials.